Welcome and thank you for joining. We'll take a look at a homework question from lesson U2 L1A. We have to find the equations of both lines that are tangent to the graph of f of x equals x squared and pass through the point 1, negative 3. Now let's read the question a second time. And now we have to also write the information down, what is given, what is required, so that we can see the information and hopefully find some connection. And if possible, always draw diagrams. The more diagrams, the better. A picture is worth 1,000 words. I know it sounds like a cliche, but it is so true. So here we go again. So we have to find the equations of two tangent lines that are drawn to f of x equals x squared. So here we are. We're going to start off by drawing the graph of f of x equals x squared, which I will magically draw right now. So I had prepared that in advance, obviously. So this is a graph of the parabola with a vertex at 0, 0. Now you know how to draw the graph of a parabola in 5 seconds. So you start with a vertex here. You always go over 1, up 1, and then over 1, up 3, over 1, up 5. So remember, you go always over 1, and then you go up 1, 3, 5. You see, it's all the odd numbers. So if you want to keep drawing the parabola, make it bigger. So you go over 1 and up 7, over 1, up 9, and so on. We're not going to do that, so don't worry. So here is the parabola. And what we are doing is drawing a tangent line to this parabola. Wait a second, I can draw so many tangents to this parabola. Which ones do I have to draw this time? Well, it says that the tangent should pass through the point 1, negative 3. So let's see, where is point 1, negative 3? So 1, negative 3, this is x equals 1, and this is y equals negative 3. And point 1, negative 3, which we are going to give it a name because why not? So we're going to call it point A. It's right here. So if we are drawing tangents to this parabola, it seems that we're able to draw two of them. So here goes the first tangent line from here onto the parabola. So that's one tangent line. And we can also draw another tangent line if we use the other side of the parabola. Let's see. Here we go. So we're going to call these two tangent lines the tangents L1 and L2. And the question is asking to find the equations of both lines. Now, I like to start off with a general equation about both of them because I need a starting point. And the best equation to start with for any line is y equals mx plus b. So I will write for the tangent line L2, y equals mx plus b. So in order to find the equation of a tangent means that we need to know what the slope and what the y-intercepts are. So this is going to be our next step. So how do we find the slope and how do we find the y-intercept? Now let's take a look at what we're given. So we know that the tangent line will pass through the point 1, negative 3, both of them. So this point will belong to both tangents, which means that these coordinates must satisfy both equations. So we are going to substitute the x and the y in both equations. So y is negative 3, x is 1. Y is negative 3 and x is 1. Now the next thing we have to think of is the slope. So remember that this slope in here, the blue slope and the purple slope, will be two different slopes because they're drawing at two different points on the parabola, and you can tell that their steepnesses are different. So you see this is a negative slope and this is a positive slope. And now I'm thinking, how do I usually find the slope of a tangent? So what are other names for the slope of a tangent? Well, I know that slope of a tangent and derivative means the same thing. So what that means is if I want to find the slope of the tangent on the graph of this function, at any point on the graph of the function, I can simply differentiate this. So we're going to say that the slope of the tangent, and we're talking about the slope of the tangent at any point on f of x equals x squared, would be equal to the derivative f prime x, or in other words, the derivative of x squared. See, that was an ugly x squared. Here we go. And that would be 2x. So for example, if you want to know what the slope of the tangent is in here, As long as you know the x value where you're drawing the tangent, the x coordinate of the point where you're drawing the tangent, then you can simply substitute the x in here. It will tell you exactly what the tangent is. So let's give it a try actually. Let's say that we are finding the tangent at x equals -3 here. So we're going to go, okay, multiply 2 by -3. The slope of a tangent should be -6. Let's say you are at -2. The slope of a tangent, 2 times -2, -4. If you are here, 2 times -1. If you are at 0, 2 times 0, that's the slope of the tangent, and so on and so forth. So you can find the slope of the tangent in between point and 1 points. At 1.5, the slope of the tangent will be double of 1.5. So remember that we can draw an infinite number of tangent lines in here. But there are only 2 tangent lines that will be tangent to the parabola, obviously, but also pass through the point with coordinates 1 and -3. So these are 2 very specific tangents that will touch the graph at 2 very specific points, which we are going to call, let's say, the points P and Q. So the points P and Q. So now, we are going to have to find the equation of the tangent, so always keep an eye on whatever the main question asked is. But in the meantime, explore and try to understand whatever information is given on the diagram, whatever information you're given, and try to interpret it in multiple ways, because that develops and deepens our thinking skills and our understanding of how to solve problems that we've never seen before, for example. So here we are. We're going to think of the slope of the tangent, which we just figured out that it can be they can both be interpreted by this expression 2x. But that doesn't really solve our problem, because if I'm given that the slope of the tangent will be equal to 2x, I don't know exactly what the slope is going to be, because I don't know what the x value is at the point of tangency for either one of these points. So now I'm thinking, since 2x will be the slope of the tangent at any point, is there a more specific way that can help me find the tangent that is drawn from this specific point on the grid? So a tangent that comes from 1, -3. And what we're going to do is actually try to write the equation or the slope of the tangent by using this point in here and the points either P or Q. So remember that points P and Q will be points on the graph of the parabola, and any point on the graph of this parabola will have the coordinates x and x squared. So any point. So we're going to say that the point P will have the coordinates whatever x is, then the y coordinate will be x squared. So if you are drawing the tangent that passes through the point 1, -3 and x squared, then we can in some way create an expression for the slope of the tangent that will pass through specifically point A. So let's get started. We're going to try to find the tangent line or the slope of the tangent by using the equation delta y over delta x. I'm actually going to make this white, because it will give us both tangents in a way. So since the 2 points that we're using are these two, then we're going to go delta y x squared minus -3. So x squared minus -3 over delta x. So for delta x, you see we have x minus 1. So this would be the slope of the tangent actually from A to any point on the parabola. Now, and 2x will be the slope of the tangent at any point on the parabola, so it doesn't matter where they pass through. So, but we do know though that, let's write this in more simplified form, so x squared plus 3 over x minus 1. So this will represent the slope of the tangent that passes through the point A, which is 1 and -3. So if we're finding the slope of the tangent as 2x, which again represents the slope of any tangent drawn on the parabola, or x as x squared plus 3 over x minus 1, which actually is more specific because it tells us the slope of the tangent to the parabola but that passes through the point A. And that means that we're talking about the same slope. So that means 2x must equal x squared plus 3 over x minus 1. So we'll write that down. So 2x equals x squared plus 3 over x minus 1. And now what we have to do is solve this equation. So let's see what we obtain here. So we'll multiply 2x by x minus 1 equals x squared plus 3. So we have 2x squared minus 2x equals x squared plus 3. All right, let's continue a little further down here. We have 2x squared minus x squared minus 2x minus 3 equals 0. So remember, we're taking x squared to the other side to become negative. It will become negative. Plus 3 to the other side becomes negative. Let's simplify a bit more. We have 1x squared minus 2x minus 3 equals 0. So we obtained the quadratic equation. Let's solve by factoring. It seems to be factorable. So x will be the first term. Two numbers that multiply to negative 3 but have a sum of negative 2 must be negative 3 and positive 1. So that means that either x minus 3 is 0, which will make x equal to 3, or x plus 1 is 0, which means that x must equal negative 1. So it seems that we are drawing the tangents at x equals 1, x equals negative 1 and x equals 3. So it seems that our tangents are kind of accurate in here. Here we go. So at negative 1 and at positive 3. So all the way here. That's where the point P is located. So at positive 3. So now that we have the coordinates at the point of tangency, we're going to say, okay then, so this tangent in here, the blue one, the blue tangent, is at x equals negative 1. So that will make the slope of the blue tangent equal to 2 times negative 1 or negative 2. And the slope, the tangent that is drawn at the point P will be at x equals 3. And the slope is 2x. But now we know what x values are where we are drawing the tangent, which means that the purple slope here would be equal to 2 times positive 3, or the slope would be 6. Now, you see, we have a lot more information in our hand, and we're going to start off by finding the equation of the blue tangent. Here we have the value of y, which is negative 3. So we'll write that down, equals the value of the slope is negative 2. So this slope here is negative 2. And the value of x, which is positive 1. And we are missing b, but we have no problem with it because b is the only unknown in this equation. And that would be negative 3 plus 2 or negative 1. So therefore, we're going to say that the equation of one of the tangents will be y equals negative 2x minus 1. And in the similar way, we have to find the equation, I should say in the same way, we'll find the equation of the purple line. And you can see this is going down, it's touching the graph at negative 1. I think we did a great job graphing the parabola there. So we're going to do we're going to work on the next equation of the tangent with a slope of 6. We're going to say that the y value is negative 3, as you can see. The slope is positive 6, x is 1. So we're going to say negative 3 equals 6 times 1 plus b. And let's find b. Negative 3 equals 6 plus b, which makes the value of b equal to negative 3 minus 6 over negative 9. So therefore, we're going to say that the equation of the second tangent will be sub 6 x and minus 9. And that would be the equation of the second tangent. And here we go. We found both tangents in slope-y-intercept form. If you want to write the answers in standard form, no problem at all. All you have to do is take all the terms to one side of the equation. I'm going to quickly do it right here. So that would be 2x plus y plus 1 equals 0. And this one would be 6x minus y minus 9 equals 0. So we have both the standard and slope-y-intercept form. So I hope this made sense, and I hope you understood each and every step. And if you have any questions, let me know in the comments. Try to do this or a similar question on your own. Try to create an equation on your own. That shouldn't be difficult. So just create a quadratic equation and try to draw a tangent from some point on the Cartesian plane. So try to recreate a similar problem and articulate all the steps using your own words. All right then, thank you for watching and bye for now.